Okay, so I want to look at this example first. What would I expect someone to think that this means? 3 to the fourth power. What does that mean? Not what it equals. What does it mean? Yeah. It means 3 times 3 times 3 times 3. And then we can figure out what it equals from there. We could go 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So that's one way to think about this. So if that's true, when we look at this here, what does negative 3 to the third power mean? Negative 3 times negative 3 times negative 3. And then what does negative 3 to the fourth power mean? Yeah, so see, there's 2, there's 3, and then there's 4. So how many negative 3's did I write up there? 7. So, okay, so let's take a look at the first two examples. This says 2 to the third times 2 to the fourth. Well, 1, 2, 3, 4, 5, 6, 7. And their answer came up to be 2 to the seventh. This is the same thing. It says 3 and 4, and I wrote 1, 2, 3, and then I wrote 1, 2, 3, 4, and together they made 7. So without doing all that repeated multiplication, what could we say when we're multiplying things that have the same base with exponents? What could we do? Think about it for a second. What's something that happened between these two numbers to get me to that number? How do I get 7 out of 3 and 4? Add them together. So here's what we can say. If I am doing exponents that have multiple, that has the same bases, right? For example, the next one says 7, right? They both have 7 as their base. What do we think the answer is going to be over here? 7 to the fifth power. So if they're the same base, I can simply just add the exponents. That's true. Now, how about look at this one here? This one here is kind of interesting. 5.1 times 5.1 to the fifth. What do we know it's going to be 5.1. What do we think is going to be here? To the sixth. Good job. Who said that? Nice job. Listen, so 5.1, whenever there's not an exponent, we have to assume it's the number 1. Okay? If it's not written, we assume it's the number 1. So then when we look at negative 4, what should it be? Negative 4 to the fourth. Very good. All right, do the next 2 on your own. You should have gotten 10 to the eighth. Cool. And then you should have got 1/2 to the. Now this is important. You need to make sure you leave it inside the parentheses. And you'll learn about that why on Wednesday for that. But you need to make sure you leave it in parentheses. What do we think about x times x to the fifth, what should it become? X to the sixth. Very good. And then y should become y to the 11th. Awesome. All right, so now the next thing is we got the rule. It's called a power of a power rule. So the first thing I want you to think of is when we were doing this a second ago, someone told me that 3 to the fourth meant 3 times 3 times 3 times 3. None of that's changed. That's still exactly what that means. But if we look at this here, 3 to the second power in parentheses, and then we go with the 3 on the outside, just based on what you guys said earlier, that really means 3 squared times 3 squared times 3 squared. Does everybody understand how I got there? Seriously? So, okay, so look. When we had 3 to the fourth, right? It was 3 times 3 times 3 times 3. So the 4 told me how many times I was going to multiply it by itself, okay? This 3 tells me how many times I'm going to multiply it by itself. Does that make sense? The 2 just stays there. Now, in the previous problem, we learned that if it's written 3 to the second, 3 to the, like this, we could just add them, right? So this is going to become 3 to the 2 plus 2 is 4 plus 2 more is 6, right? Now look, when it's, what could I have done? How could I get 2 and 3 to equal 6? How could I get 2 and 3 to equal 6? What operation works for 2 and 3 to equal 6? 3 times 2, right? So if that's the case, right? If I could just multiply these. Hello? I already did. All right. He can come back after you talk to him. All right. Later. So here we multiplied 2 times 3, which gave us 3 to the 6th. Now, if we keep that same pattern going, what do we think 2 is going to become to? To the 8th. To the 8th. And 7 is going to become 7 to the 9th. Now, 1/3 is going to become 1/3 to the, it stays inside parentheses, 1/3. How are you getting the 10th and 11th? Huh? It's the 6th. You're just multiplying these two numbers together. So x is going to become x to the 10th. And y is going to become y to the 8th. Man, your dad's going to have a field day when I talk to him later. X to the 10th. Again, it's the same one as before. So in the previous section, when they were written like this, right, I add the exponents. So we add exponents or powers, depending on whoever your teacher is, whatever they want to call them, exponents. But so when I multiply, when I'm just straight multiplying, I add the exponents. But when I'm doing an exponent to an exponent, I'm going to multiply them. So when I multiply numbers that have exponents, I really add the exponents. When I'm doing a exponent to an exponent, I'm going to multiply them. So what about when I'm doing the quotient rule? What do you think I'm going to do? Quotient means divide. When I'm dividing numbers with exponents, what do you think I'm going to do? When I multiply, I added. What do you think I'm going to do? Hello? Yes. Absolutely would have done that. Yep. Thank you. All right. Bye. All right. So when I multiplied just the numbers with exponents, I added them. What do you think I'm going to do when I divide them? Yeah, I'm going to subtract them, and here's why. Check this out. If I write this just how it is, -4, that would be times -4 times -4 times -4, and then I wrote on the bottom side what it says to do, times -4. I can cancel out the ones that are on top of each other that are the same. And I'd be left with just simply -4, -4. And so it'd be -4 to the second. So that means I can subtract when I'm dividing. So 8.5 would become 8.5 to the what power? It's 7 and 2. Yeah, we can just subtract them. 8.5 to the fifth. And then x to the sixth over x to the third would become x to the third. And y would become y to the first. Now, here's the interesting part. Do I have to put 1 here? Do I have to put a 1 there? No, I don't. I can just write it as simply y. We assume that any number that doesn't have an exponent has a 1 as the exponent. So z would become z to the, this is a trick question, z would become z to the, they're both 6. 0, but here's the problem. Let's think about this. Z to the times, we'll do z to the second because we'll have to do as much. Z to the second, z to the second. Z times z, right? And then I did z times z on the bottom, right? And I canceled them out just like I did before. What's left? 0. There's nothing left, right? Now here's the tricky part. Whenever everything's exactly the same on top and the bottom, let's say it was the number 4, what's that equal? 1. Z over z, right, is equal to, anybody know? Take a good guess. 1. Anytime you have a fraction where everything is the same on the top and everything's the same on the bottom, it equals 1 every single time. So here's what we know for sure. Z to the 0 is equal to 1. Here's something interesting. 6 to the 0 power is equal to 1. 1 billion to the 0 power is equal to 1. Negative 1 million to the 0 power is equal to 1. So what can we say about the 0 power? It's 1. Anything that has a 0 power is the number 1. All right, your assignment for today is to go back and do... Huh? There's some assignment. This is the notes and stuff. You'll get credit for this too. Your assignment is to go back to do rules of exponents. You're going to click here. So, and then click preview. You'll have a few questions there. I think there's 10 or 12. I'm not quite sure. 11, 10 or 12. I was close. So, you'll answer these 11 questions. Try the best you can. Now, we didn't do one. I want you to take a look at question 2. We're going to do this one together. So, the only part that has an exponent is e on this. E to the third times e to the third will become e to the what? 6, right? We just add them. But you still have to do 3 times 7. 3 times 7 is 21. So this is going to become 21e to the 6th. And then the other part of this is you do this the same way. C to the second times c to the 6th is going to become c to the 2 plus 6 is 8, number 3. And d to the first times d to the fourth is, or d to the third is going to become d to the 4th. So this is going to become c to the 8th, d to the 4th. And you'll look and see that it's one of the ones listed. So even though they're not like directly side by side, means you can still do them.